Welcome back to the Science Hub SKB. Acids and alkalis. Part 1. Definition of an acid, properties of acids, definition of a base, properties of bases, definition of neutral substances, properties of neutral substances. Have you ever tasted a lemon or a sour orange and felt your lips pucker up? The tangy taste comes from something called acids. Acids are like tiny superheroes in the foods we eat. They make lemon sour, oranges tangy, and even help make fizzy drinks bubbly. Acids are not just in the kitchen, they are all around us. They help with cool things like making car batteries work and keeping our stomachs healthy. An acid is a substance that releases hydrogen ions when dissolved in water. In other words, it's a solution that contains a lot of hydrogen ions. They can exist as a solid, a liquid, and a gas. Acids can be classified as either strong or weak based on how well they release hydrogen ions when dissolved in water. All acids should be handled with care due to their corrosive nature. Goggles should be worn to protect the eyes and gloves to protect the hands. Corrosiveness is the ability of a substance to destroy, damage, or degrade another material, often through a chemical reaction. The corrosiveness of an acid is dependent on their strength, concentration, duration, and the material that they are interacting with. Acids can be corrosive. They turn blue litmus red. They have a pH of less than 7. They turn universal indicator from green to red, yellow, or orange, and they have a sour taste. Examples of everyday acids. Ethanoic acid can be found in vinegar, citric acid can be found in lemon juice, lactic acid is found in sour milk, tannic acid in tea, ascorbic acid in fruits and vegetables, hydrochloric acid in the stomach, tartaric acid in grapes, oxalic acid in tomatoes, malic acid in apples, and formic acid found in the sting of ants' bites. Examples of laboratory acids are hydrochloric acid, which has the formula HCl, nitric acid, which has the formula HNO3, and the sulfuric acid, which has the formula H2SO4. Please note that these are very strong acids. Have you ever helped wash the dishes with soap or watched someone bake a cake? Well, guess what? Those things have a special helper called an alkali. They help clean greasy dishes, make cakes rise fluffy and tall, and even keep our swimming pools safe to swim in. An alkali is a type of base that dissolves in water to release hydroxide ions. In other words, an alkali is a solution that contains little hydrogen ions. They can also exist as a solid, liquid, and a gas. Alkalis can also be classified as either strong or weak based on how well they release hydroxide ions when dissolved in water. All alkalis should be handled with care due to their corrosive nature. Goggles should be worn to protect the eyes and gloves to protect the hands. The corrosiveness of an alkali is dependent on its strength, concentration, duration, and the material that they are interacting with. Alkalis are also referred to as bases. This is because they dissolve in water and produce a basic solution. The term alkali refers specifically to those bases that are water soluble. All alkalis are bases, but not all bases are alkalis because some bases do not dissolve in water. Metal oxides and hydroxides tend to be bases. An example of metal oxide is sodium oxide, while an example of a metal hydroxide is sodium hydroxide. Properties of alkalis include that alkalis can be corrosive if concentrated. They turn red litmus blue. They have a pH of more than 7. They turn universal indicator from green to blue or purple. They have a bitter taste and they feel soapy to the touch. Alkalis are used every day. Here are some examples. Baking soda, also known as sodium bicarbonate, which has a formula of NaHCO3. Soap, which is also potassium or sodium hydroxide. It has a formula of KOH or NaOH. Ammonia, which has a formula of NH3. Washing soda, also known as sodium carbonate, has a formula of Na2CO3. And toothpaste, which often contains sodium hydroxide, which has a formula of NaOH. Examples of alkalis that are used in the laboratory are sodium hydroxide, NaOH, ammonium hydroxide, NH4OH, calcium hydroxide, Ca open bracket OH close bracket 2, magnesium hydroxide, Mg open bracket OH close bracket 2, and potassium hydroxide, KOH. Neutral substances are like the peacemakers that aren't acidic, like lemons, or basic like soap. They are right in the middle. They help balance things out and keep everything from getting too strong in either direction. Properties of neutral substances include that they do not react with acids or bases, they tend to be harmless, they do not affect litmus paper, they have a pH value of 7, do not cause any color change in universal indicator, and vary in taste when ingested. Pure drinking water tastes bland. Some examples of neutral substances are water, H2O, sodium chloride solution, which is actually salt in water, NaCl in H2O, sugar solution, C6H12O6 in H2O, cooking oil, sand, and air. These neutral substances are all around us, quietly keeping things balanced. Comprehension. What is an acid? What is an alkali? What is a neutral substance? An acid is a substance that releases hydrogen ions when dissolved in water. Or, an acid is a substance that contains a lot of hydrogen ions in it. What is an alkali? An alkali is a type of base that dissolves in water to release hydroxide ions. Or, an alkali is a substance that does not have a lot of hydrogen ions in it. Neutral substances are materials that have a pH of 7, indicating that they are neither acidic or basic. In neutral substances, the concentration of hydrogen ions is equal to the concentration of hydroxide ions. Comprehension. List 3 properties of acids and list 3 properties of alkalis. 3 properties of acids are: they have a pH of less than 7, they are sour, and they are corrosive. While 3 properties of bases are: they have a pH of greater than 7, they have a bitter taste, and they feel soapy to the touch. Comprehension. What type of acid is present in lemons, vinegar, sour milk, and grapes? In lemons, we have citric acid. In vinegar, we have acetic acid. In sour milk, there's lactic acid. And in grapes, there's tartaric acid. Comprehension. out the table with the correct responses. So in acid, we have malic, formic, and tannic, and then we have to give the locations of each of these acids. And then in location, we have vinegar, sour milk, and lemon. So we have to give the acids that are found in these locations. Congratulations, did you get it right? Yay! So we find malic acid in apples, we find acetic acid or ethanoic acid in vinegar, lactic acid is in sour milk. We find that ants contain formic acid and lemons contain citric acid, whereas tannic acid can be found in tea. Fill out the table with the correct responses. So we'd like to know if the mixture is an acid or a base. Yay! I'm so proud of you. So we have sodium hydroxide, calcium oxide, and magnesium hydroxide as the bases, and then we have hydrochloric acid, sulfuric acid, and nitric acid as the acids. Great job, students. Wow, we're at the end of part 1. Congratulations. See you around for part 2. Bye.